All right, so good news is that this class should be easier than 470.
Sure.
Bad news is it's going to be the second hardest class. It shouldn't actually be the second hardest class. We'll talk about it. All right, so why does that say this is not fundamentals? But that's like from years ago. That's a copy from years ago. No, this class is systems programming. And we'll talk what that means in a little bit, but it's your normal. I did change one thing. So first of all, there is a textbook for this. You go to zybooks.com and you put in this little code thing here, and the book is a C programming book that has a bunch of interactive things with it and stuff like that. So you will definitely need that. I will be giving you reading assignments and expect you to complete some of the interactive stuff from there. Blah, blah, blah. There's also 2 supplementary books that we're going to use. I have them linked up here on content. These are both open. O'Reilly has open source stuff for education. We might not have direct assignments out of these. I don't know yet. But if we do, it'll be out of the systems programming book, probably not the kernel one, but we're going to talk about both of these. But these are both PDFs of some books that we'll talk about dealing with Linux. Blah, blah, blah. Here's a bunch of crap. One change that I did this semester from previous semesters is I have homework assignments being 60% of your grade, and then still pop quizzes exist, but they'll count as assignments. The advantage of that, it actually probably benefits some of you, is in a class where you maybe don't have as many quizzes. If you miss one, then you have this like 20% average for 20% of your grade or something like that. So this is just one more homework assignment in the big collection of homework assignments. So it probably actually benefits you if you have crappy attendance. The usual midterm final, I'll replace your midterm with your final if you do better on the final, blah, blah, blah. All right, questions about that stuff? Go ahead.
So are we still doing that?
Yep.
Did you decide to do it the half page then?
Well, did you look at the class yet?
Huh?
Okay,
Okay, I didn't. I'm trying to get this
Terrible. So you didn't trust me to take the feedback? Is that what it is? That's what it sounds like.
Oh, I was just asking.
But you didn't have to ask. The information was already there.
No, but I wasn't looking at it.
We're just off to a bad start already. That's how it goes. All right. So any useful questions? Okay. So make sure you get the Zybook. You'll need that as soon as possible. I already have links up here for the lectures and the slides, even though those don't have things in them yet. We'll also be using a tool in here called Cloud9, which I'll actually introduce as part of today's lecture. So I won't talk much more about that right this exact second. You got your self-assessment crap here, and then also Slack. If you're not on Slack, make sure you get on Slack, join the 450 class, and then set that up for push notifications in case I send you some sort of announcement or something like that. Here's the threat is I might have quizzes where I put some sort of like secret word up on Slack, and then you have to come into the quiz and put that word down, like what was the secret word. And if you weren't on Slack and you didn't get the notification, then you'll get a 0 on a quiz that you could have easily got 100 on. So get on Slack. It takes like 3 minutes. And put it on your cell phone and do push notifications for at least the 450 class. Okay. Questions about any of that stuff? All right. So then let's dive in. So What do you think systems programming means? Or is it just that we had to have another name for just another programming class? What's a system? Just a lively bunch. The guesses are acceptable at this point.
Operating system?
Operating systems would probably be an example of a system, given that it has the word system in it, right? Okay, so if we kind of break that down a little bit more, what is an operating system? Okay, so those are some of the components of an operating system. Generically speaking, what is an operating system?
It's a collection of various items that cause something to run. In this case, it'd be the computer, so it'd be a collection of the things you need to make the computer run.
Okay, so specifically for operating systems is because we don't really have the ability to, like, you know, take two circuits and hook them together. We need a piece of software that sits between us and the hardware to make the hardware do stuff. Now, if we abstract that and say, well, anything that kind of glues between two pieces, we have systems for. How many of you have heard of things called a controller? You know, we have various microcontrollers for different things. Usually they're, from a non-technical person, it sounds complex, right? That's something, oh, you know, this is the controller for X, Y, and Z. And the reality is that we can think of an operating system like Windows as being the controller for our general purpose computing hardware. So really the operating system is doing a lot of stuff, right? If you had iPhone or Android programming, an activity would be like a controller or why can't I come up with a name for a view controller? It has the word controller in it. View controller for iOS has the tools in it for controlling things having to do with a view. Those are substantially simpler types of things than an operating system. So when we think about a general purpose computer, there's a whole bunch of stuff that needs to be controlled, right? All right, so systems programming is writing software in terms of the controller. Let's just do this. For a system. So examples might be Linux, Windows, Mac OS. Those would be, you know, complex types of controllers. All right. Simpler things might be the controller for a elevator. You know, it's a piece of software that just makes the elevator go up and down, stop at certain floors, that kind of stuff. Much significantly less moving parts, but also very important, right? Okay, so, but from our perspective, we want to think about our systems and the general purpose being operating systems. Okay, so then the follow-up is how do operating systems work? We kind of at the high level have said that they sit between us and the hardware and somehow magically let us use the computer. But how is that actually accomplished? How do our modern operating systems pull this off? You mentioned a couple of some of the individual pieces, right? Okay, so we have this thing called the kernel. What's the kernel?
The hardware.
Okay, so maybe we call this, if we want to think about, let's just make a kind of a weak connection first. This is kind of almost the CPU of the operating system. This is the core operating system, is the kernel. Everything else is kind of a component of that kernel. Now, modern operating systems typically use a microkernel with modules. Older operating systems had kind of a larger kernel where everything was connected together, and one thing breaks, other things could break, and things like that. But one of the components of our kernel, of our operating system, would be the kernel. So this is the core OS. Really important stuff that is dangerous to modify. Okay, so that's the whole idea of this idea of a microkernel. I'll just write the word down. We're not going to talk about it at this point, but a microkernel is put all the important stuff in one little piece and then say don't touch unless you know what you're doing, and then surround that guy with modules that do some of the other stuff that are less dangerous if bad things if something goes wrong. All right, what else goes into an operating system? The who? File system? All right, so we have our file systems. What are some example file systems? How many of you are Windows users today? What file system do you use in your computer? Are you serious? You don't know what file system you use in your computer? Who? NTFS. NTFS. What does that stand for? New Technology File System. All right, so since we hit a home run on this one, where does this guy come from? So we go back to history of OSs. What's the oldest OS that you've heard of? Let's just think of the Windows line. What's the oldest Windows you've heard of? MS-DOS, okay. So really, it's Microsoft line, which is really what I intended to ask, but so you're ahead of the game. All right, so MS-DOS. All right, there was a whole bunch of versions of MS-DOS, right? And then finally, we decided to have a graphical user interface, right? Where did that go? What was the first Windows distribution with a graphical user interface that people really heard of? Yeah, Windows 3.1. All right, what came after Windows 3.1? Windows 95. Yeah, there was another little dude here in the middle. Yeah, which one? We're getting a little bit dated here, but so this is at this point where this is less embarrassing than not knowing that you run NTFS today. So this was Windows NT 3.51. It's the dude that kind of sandwiched in there. All right. What came after Windows 95? We'll write it down, but there's one other guy in there. What was so we'll pause here. I'll actually just write it in here. Windows NT4. What's the difference? Oh, well, actually, let's talk about here. What's the difference between MS-DOS and Windows 3.1? What did Windows 3.1 bring to the table? We've already mentioned this. Yeah. Mouse. Clicky stuff, right? Things that we take for granted today, but MS-DOS only had text. All right. So Windows 3.1 brought graphic user interface to the table. So this brought us a GUI. What did NT bring us initially? Really two things. But one thing was the thing everybody talked about at the time. It's something we take for granted today. Maybe it's the thing to think about is what did Windows 3.1 not have that we take for granted today? Multitasking. Computers used to not be able to do more than one thing at a time. Now we have a zillion applications open at once, right? That wasn't a thing for a long time. All right. What did Windows 95 bring to the table? Well, here, actually, let's throw an additional thing here. This brought multitasking and also brought NTFS. What file system did Windows 3.1 use? Fat16, but yeah, you're in the right page. Just used Fat16. File allocation table 16. Now, how many of you use the FAT file system today? In what?
Mac.
On your Mac? Not for your Mac operating system. Yeah, you use a Unix file system for your Mac operating system. Yeah. Flash drives use Fat32, 32-bit version of that. Why is that? When you go out and you buy a new, external hard drive or a USB flash drive, they come pre-formatted FAT32. Now, can you reformat that? Can you change it to something else? Sure. Why do they come pre-formatted FAT32? What's the advantage of that? With what? It's not a USB thing. What kinds of machine? Yeah, what kind of machine might you plug your USB stick into? Mac or a Windows machine? Absolutely. NTFS does not. NTFS does not. exFAT is a Mac's implementation of FAT. Nobody uses it. That's only if you're going to format an external hard drive that you wanted to have available for both, but almost always you're better off formatting it on Windows and then using it on both. Okay, so punchline here is that Mac and Windows and Linux, basically pick your operating system, they all understand FAT32. They understand the FAT file system. So you're going to get the compatibility across those things. So if we come to another screen here, FAT32, pros, I'll just say compatible. Perfect. What about cons? Who? Character limit? Actually, that is true. That is true. That's interesting you said that. That's not a common thing that people really complain about, but that is a true statement. There is a character limit for file names in the FAT file system, which is kind of sucky, but that's why sometimes when you're at the DOS prompt or something like that, you'll see it like they'll shorten a thing with a little tilde and that kind of stuff. But bigger con. What's the bigger con? Maybe you go ahead. 4 gigabyte. If you've ever had a jump drive, so let's say you have a 32 gigabyte USB stick, and you try to store a 5 gigabyte file on there, an ISO or an MP3, or a pretty big MP3, probably an illegal movie. Makes more sense. So a rip of a Blu-ray, maybe. And what does it tell you? If you try to put a 5 gigabyte file on a FAT32 USB stick, even if you have 16 gigabytes free, it says out of space. Because the largest file size that a FAT32 file system could hold is 4,096 megabytes. It's 4 gigabytes. So anything bigger than a 4 gigabyte file won't fit. So sometimes that's the motivation for going to one of the other file systems, either the Mac OS, which is a Mac file system, which is a Unix FS, or NTFS, which does not have, there is a file size limit to those. I don't know what it is, but it's big, a lot bigger than we're dealing with today. All right, so cons is limited single file size. Back in the days of FAT16, and even early days of FAT32 before they went full 32-bit, we had some other interesting issues. So how many of you had a machine running Windows 95? Okay. So this, this is kind of going with not just history of operating systems, but history of computing. Around the same time is when hard drives started getting a lot bigger. Right? So when Windows 95 was first out, it was pretty common to have a, 600 megabyte hard drive. A hard drive that was substantially smaller than a gigabyte. Where today, what's the smallest hard drive in any of your computers at home? 128 gigabyte. But a lot of computers come with a terabyte, which is 1,024 gigabytes, or 2 terabytes, or 4 terabytes, or whatever it is, right? And most of the time today, the reason why your hard drive is smaller is because you're using a newer technology, like a solid state. So you can get a 1 terabyte solid state drive, it's just expensive. So typically you would say, I'm going to get a 256 gigabyte solid state drive. So it's a way, way, way faster hard drive, but I have less capacity because that's what I could afford, something like that. All right. But back in the Windows 95 days and Windows 3.1 days, our hard drives weren't that big. Your computer may have come with 8 megabytes of memory, 8 megabytes of RAM, and maybe 400 megabyte hard drive, something like that. But then pretty quickly, the price of memory started coming down. I think in one of my other classes, you've probably heard me give the example with RAM, that once upon a time, an 8 gigabyte or an 8 megabyte RAM stick cost $1,000. Where now you could accidentally walk in and pay full retail for a 4 gigabyte stick and it's like $30 or something like that. And that's if you don't decide to shop online. Okay, so in any case, this was kind of during the time period where hard drives kept getting bigger and bigger and bigger. And you had a problem with FAT16 where, let's say you got a 4 gigabyte hard drive, which was once upon a time considered giant. You couldn't create a 4 gigabyte partition on that drive. The biggest single partition you could create was a 2.1 gigabyte partition. So even though you had a single drive that was 4 gigabytes, you would have to split it into 2 logical drives in the operating system, a C drive and a D drive, let's say, each being 2 gigabytes, in order to use the drive. Okay, so all this stuff ultimately goes back to, 16 bits versus 32 bits versus 64 bits, these subsystems in the operating system and what bit width they're implemented in terms of. That kind of goes back to where we were here, where we're talking about file systems. We keep adding to that. We might say we have the memory system. Let's leave it at that for right now. But we're also going to talk about process management. All right, so in any case, we come back here. So we have Windows NT 3.51. This brought in multitasking. It also brought in NTFS. It also brought in the NT kernel. Okay, and you've already kind of explained the kernel is like the really important part. It's at the end of the day, the kernel is actually the operating system. Windows 95 would be called a distribution, right? It's an OS distribution. When you get one of these Linux distributions, there's 4 zillion of them. So let's say you've got Ubuntu or something like that. You have the Linux kernel, and then that comes with the Ubuntu distribution, which comes with all their pre-installed software and their version of an easy-to-use graphic user interface and all that jazz. But it's sitting on top of the stock Linux kernel, just like Red Hat Linux would be sitting on top of, or Fedora Linux, or SUSE Linux, or Slackware, blah, 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 blah. All right? So the actual core operating system is called a kernel. So Windows NT introduced a new kernel called the NT kernel. So Windows 95 comes out. What did Windows 95 bring to the table? Start button. So really, let's call it a new interface that's really still existing today, right? So start button I think is accurate. So new interface. Still has the multitasking. Which kernel is Windows 95 running on? Yeah, so this guy up here, the actual operating system is MS-DOS. And up here, it didn't even have a distribution. It was the operating system. There wasn't a differentiation between the kernel and the distribution in MS-DOS. Here's the operating system. It is what it is deal. Then things started getting more modular. So Windows 3.1 ran on top of MS-DOS. Windows NT ran on top of the NT kernel. Windows 95 still ran on top of MS-DOS, but they called it the 9X kernel. Okay, so almost like they created a new version of MS-DOS with this idea of graphic user interfaces moving forward. All right, so then we had Windows NT 4, which, what did that guy bring to the table? We're really talking about the evolution of Windows operating systems here. What was the difference between the Windows NT and Windows 95? Who are the target markets for those? Like if you were a Windows 3.1 user, was it likely that you upgraded to Windows NT 351? Now your upgrade path was probably Windows 95. If you were a Windows NT 3.5 user, you probably upgraded to Windows NT 4. So we might think of the NT line as being kind of the business line, where the other line was the consumer line. All right, so what did Windows NT 4 bring to the table? Because Windows NT 3.51 still had the Windows 3.1 user interface. Windows 95 had this brand new start menu based interface. Windows NT 4 had the Windows 95 interface with the NT kernel. So you might say it looked like 95, was stable like NT. So the NT kernel is typically considered to be pretty stable, where the 9X kernel kind of is the blue screen of death poster boy type thing. All right, so then after NT4 came out, we had Windows 98. What came out next? Windows 2000. Now this was a big problem. Anybody know why Windows 2000 was a big problem? And actually, Windows 2000 is still in circulation today. There are still places that are running Windows 2000. It is up there for one of the most popular Microsoft operating systems ever. Very, very good operating system, but had a major, major, major problem. Anybody know what the big problem with Windows 2000 was? See, Microsoft decided to change this is kind of in the days where, they're flying around with different naming conventions to try to sell pieces of software. So if you were walking through the aisles of Best Buy and you were currently running Windows 98 at home and you saw Windows 2000 on the shelf, what do you think? Upgrade, newer. Big problem. Windows 2000 was not an upgrade to Windows 98. It was an upgrade to NT4. So it had the NT kernel. So now you might say, well, isn't that good? Didn't we just a few minutes ago say that the NT kernel was more stable? Right? Seems better. Don't we want the NT kernel, not the 9X kernel? But those are different operating systems. The NT kernel and the 9X kernel are different operating systems. They might look the same because now they've kind of agreed upon a user interface. They are different operating systems. And what comes with that? Why might somebody want to still operate on the Windows 9X kernel, which we've kind of advertised as being the consumer OS, versus the NT kernel, which is the business OS?
Compatibility of software.
Compatibility of software, most specifically hardware drivers. So consumers typically have computers for more general purpose, playing video games, things like that. A lot of the business applications were available for both. But when you think about, you go into the store and you buy an external scanner, or you buy a printer, or you have a new graphics card or something like that, or a new sound card you're going to put in your computer, which were all things that happened back then. What's common, you upgraded your sound card to the latest, greatest Sound Blaster. Anybody remember the Sound Blaster? Sick. So you still have one in the box. It didn't work in Windows 2000. Okay, so you would go get these things. The drivers were for the 9X kernel. So what would happen here is people would come home with Windows 2000, which was by almost every measure a better operating system than 98. But it was built on the NT kernel, which means that none of your hardware drivers worked, or very few of them. So your computer was way more stable, let's say, but nothing worked. So this was a little consumer misleading, right? If you're a consumer and you're in the store and you see Windows 2000, you're currently running Windows 98, that sounds like the upgrade for you, when it really wasn't. This was the upgrade for NT4. What came after? What was the next consumer line? Yeah. I didn't say the next upgrade. So we had something called Windows ME, Windows Millennium. Okay, and when Dell first had machines coming out with Windows Millennium, they quickly instituted a program to upgrade back to Windows 98. So that was the but now this was a very interesting operating system because this was the death of 9X kernel. That was the end of the line. Windows Millennium came out, still ran on the 9X kernel. That was the last one that came out with a 9X kernel. So what came out after ME? Windows XP. So Windows XP unified the business and consumer OSs. So Windows XP, which many of you had, maybe some of you still have. Right? And XP is very popular Microsoft operating system. Is based on the NT kernel. So really what was it? It was the first operating system that had the stability of the NT kernel with the driver support of the 9X kernel. So it's the point when the industry decided, okay, we're killing this guy off, we're all in here. Okay? What came after Windows XP? Windows Vista. Is this off of memory or is this a... Okay, well, good. So Windows Vista. Not an incredibly popular operating system, but really not a bad operating system. Really had kind of a bad rap. What were people's complaints about Windows Vista?
Slow.
Okay. I think there's truth to that. Maybe slow is I think inconvenient is the better word. The operating system itself wasn't innately slow. It was, it constantly was asking you, are you sure you want to do this? Are you sure you want to do this? Are you sure you want to do this? To the point where it wasn't convenient to use your computer. So ultimately your productivity went down, slowness, but not because of the technology, but because of the annoyance. Yeah.
They also rushed it out, like it wasn't ready to release, and they released it anyway.
Okay, and why do you think they rushed it?
People were expecting a new operating system, and even though it wasn't ready, they just wanted everybody to be happy that there was one out, even though it ended up being like the worst one ever.
Yeah, see, and that's kind of where I think it gets a bad rap. I really don't think it was a bad operating system. It was almost an operating system out of necessity. This is the period of time where Microsoft, and not that Microsoft ever lost this level of dominance, but this is probably the point in time where Microsoft had the biggest dominance in desktop installations. I mean, it's still really, really high. Okay, I don't know what it is today. Microsoft has 93% of desktop installations of operating systems. It's still ridiculously high. But at this point in time, it's like 99. Okay? The idea of having a lot of people with Mac laptops. That's where Apple really made their installation numbers go up by 3% or something. It's because you had a lot of people moving over to Apple laptops because they were cool or whatever. But Microsoft really has had dominance in the desktop market forever. Now, with that in mind, the bad people on the internet, they're the ones who write viruses and things like that, right? Okay, now if you're one of these jerks that writes a virus, are you targeting the 4 people that are running Mac OS, or the 2 people that are running Linux, or the zillions of people that are running Windows? The zillions running Windows. So Microsoft has this giant target on their back, right? Because all the people that are doing bad things on the internet. Keep in mind, the internet's a major, major thing at this point. In these early days, there wasn't an internet. Now, you were maybe very late stage Windows 3.1 was dial-up a thing. The internet wasn't even really starting to be a thing until Windows 95. And the internet wasn't really ubiquitous all over the place until probably Windows 98 time period. Okay, so now we're at the point where everybody has the internet, in the Vista time period, and Microsoft's the biggest target. Out of necessity, they had to make an operating system that tried to lock down the whole thing. So it really taught Microsoft a lesson and taught consumers a lesson as well. All Microsoft was trying to do was protect us. Because we were a giant target. Our stuff could get destroyed. But then all of a sudden we realized that, yeah, that's bad. But We're only willing to deal with inconvenience to a certain point for that. And Vista crossed that line. Okay, so Vista asked too many questions, to try to protect us. We want to be protected, but not that much. Somewhere in the middle. So after Windows Vista, what did we have next? Yeah. Windows 2007, which was kind of the hybrid Vista XP. Had the good stuff from Vista with kind of the usability of Windows XP. Still had much more security than Windows XP had, but many of the decisions were made for you instead of asking you whether this decision should be made. So most people liked 2007 better, even though at its heart was pretty similar to Vista. All right, and now we're right there with modern day. Now we have Windows 2010, and move forward. And then where does the business applications, business operating systems play in here? Where do we see those? Now we see them in operating systems named like Windows Server 2003, something like that. And what was that? That was Windows XP with a server module attached to it. So the core operating system was still Windows XP. So you could certainly run your video games and stuff like that on Windows Server. Now, they weren't completely identical, because now if we kind of come back to this slide and we start thinking about file systems, memory systems, a driver system, these things have variables associated with them that could be tweaked to kind of allow the operating system to be a little bit better for certain uses versus certain other uses. So if an operating system needs to be really good for single user use, like Windows XP, Windows 2007, something like that, then you might look at the memory system, how the microkernel's tuned, the file system. You might do certain things there that give you higher performance to make one user happy. But if you're a server-based operating system, the assumption is you're going to have lots of people using this machine at once, but probably nobody using it directly, or at least nobody using it directly that really cares about performance. The person who's using it is the IT professional who is installing a patch or something like that. So, it needs the work, but doesn't have to be that great. So they would tune it to meet that other audience. But really, you're dealing with the same core operating system across the board today. All right. So it was a long-winded thing, but whatever. So in any case, today what we see, as far as file systems go, we see NTFS on everything Windows. We see Fat32 on everything USB. And then we see there's actually quite a few different Linux file systems in Linux. And then the Macintosh operating system uses a Unix file system. And the newer file systems are what are called journaled file systems, but it's unimportant. From our normal user, we have different file systems. And what does a file system ultimately do? What's the job of a file system? For kind of rolling back 20 minutes or so, we were kind of talking about the parts of an operating system. What's a file system's job?
Manage and organize files that are stored.
Yeah, manage your files. So when you save your Word document, or you download an MP3, or you whatever, you have these files that sit in your computer, we typically think of if you're on a Windows machine, what does your file system look like? You have a C drive, right? Inside the C drive, you have potentially other folders. It's kind of a hierarchy type thing, right? But the starting point with anything Microsoft is you have your main hard drive, which is usually the drive letter is C. And inside of there, you have some default folders that you happen to know. Maybe over the years as an IT person, you may have said, well, anything I put in the startup folder automatically gets called at startup. That's kind of a magic trick, right? There's a folder that's there called startup, and you just happen to know that if you throw stuff in that folder, at some point during the operating system's boot process, it checks that folder and does things that are in there, right? Okay, so these are all things that you start understanding the inner workings of the operating system, things that are happening that aren't necessarily advertised. Okay, but the file system's in charge of storing your files. So not only how we interface with our files, when we click on the C drive and we see a bunch of folders with folders inside of them, with folders inside of them, blah, 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 but also how that's implemented under the hood. What kind of data structures are involved in storing your files, making sure they don't get corrupt, being able to roll back to previous versions of your hard drive or a specific file, things like that. Okay, so these are all things that file systems are doing. Modern file systems are doing a lot more stuff than old file systems used to do. Old file systems only did, basically say you have files. You can open them and you can save them. Those are your moves. And you can delete them. You got like 3 things you can do. Now we can still do those 3 things, but we can do a lot more. Same thing, memory system. What do we use the memory for in our computer? So file system really governs our hard drive. The memory system governs our RAM. Right, so that's kind of our short-term fast memory. So whenever we double-click on a program, it gets loaded into RAM, loaded into memory. So that memory system is working in conjunction with the kernel, working in conjunction with the file system. Because it's got to bring something off the hard drive, get parts of it loaded into RAM, so that your CPU can then feed off of it from RAM. Okay, so all these little modules are working together. So at the end of the day, when we say systems programming, what we're saying from an operating systems perspective is we're writing software that interfaces with these different pieces. Okay? We're kind of the people in the middle. So the simpler versions of this, which we actually don't get a lot of in typical college programming courses anymore, is like file I/O. Everything is done through databases and stuff anymore, or stored out on the internet, that we don't actually write stuff to files very often anymore. It's just not the cool thing. But we're going to do file I/O stuff. That's kind of the simple starting point. But then we have to start thinking about process management, which is another subsystem. So what if you want one process to turn into 2 processes, and each of those processes is doing a different thing? So now you're writing your, we're going to use the C programming language to pull this off, because in the C programming language, we have access to an API. And that API, the operating system we're going to use here, even though we've talked mostly about Windows here, the operating system we're going to use is Linux. And I'm going to give us an easy way to get into Linux here through Cloud9 that looks like we'll talk about next time. But that operating system has an API, which is a collection of a whole bunch of system calls, which gives us some pre-created tools for talking to these various operating system modules. Make some sense? All right, so for Wednesday, make sure you get the book. Probably go ahead and start looking through the book. If I just jump in here real quick and I go to 450. A lot of this is going to be somewhat review, but maybe go ahead and read through chapter 1 and do the parts of do the interactive stuff in chapter 1 for Wednesday. I'll say there's a slight risk of a quiz. I might give you some C code to look at, but this is really not going to give you much new stuff. This is really, hey, this is programming. This is what you've already seen, and by the way, here's a couple of examples of C code so you can kind of see what's new and what's old. Okay? All right, and then the Bible homework is already up, but it's not due till midnight on Friday. So that's the way we'll do it each week. All right, I will see everybody on Wednesday.